Welcome to our Azure Dev Meetup Munich with the second session of our Azure DevOps Series. And I'm very happy to have three colleagues of mine here, whom are Nino Loye, Mark Müller. Both of them are Azure DevOps specialists. And for sure, not least, Martin Brandl, whom's an Azure MVP. And as you can see, my fellow friend of and organizer and co-organizer of Azure Dev Meetup Munich is also here. Thomas, hello. Okay, hopefully everybody is comfortable with the situation for the moment and everything is working. If there are some issues on YouTube, please drop us a message. And hello to the folks we already know, like Gregor and so on. Thanks for joining us again. I hope you'll enjoy the meetup for tonight. Let's get started. First of all, we want to introduce you what we have tonight. But before that, let's have a short survey about you. So please go to menti.com and enter the code 650473 and follow us with a few questions about you. That helps us a lot to make the content better right now for you. Let's go with this here. Okay. We can do so. Here we go. So you don't have to follow YouTube. Okay. Go to menti.com and use the code 650473 and tell us about who's using Azure DevOps already. I don't know about the delay really. Direction is there. YouTube says we have 36 viewers at the moment, so I expect that the digit here will at least be 36 in best case. Nine. Yeah, you're right. The digits will improve over the time. You'll see. It'll take some seconds. Amazing, isn't it? This is the series session 2, so I expect we have some some people started using Azure DevOps from the session 1. And the information is that the stream shall be delayed by 30 seconds, which is huge. Looks good. 20 responses already. Okay, let's move on to the next question. So this is done. Are you already making use of infrastructure as code? And it doesn't matter how do you deploy that. It's really just that we just want to know, are you using infrastructure as code? Something like that. A local repo, GitHub, Azure Dev. Yes, I agree. It's really not that typical. But let's see, we have 3 planned there. Don't know. Hopefully we can make that one to planned. Oops. $19, come on. The 20 will make me put on the next slide. Here we go. Okay, so let's move on. That's cool. Okay, do you have any experience with deployment of containers? I guess that the funny thing is here that they have the website opened and they can see the questions there and answer it directly, whether we see it with a huge delay on YouTube. That's a bit fun for me, seeing it both. IoT Edge. Oh, oh, look of there's an expert. Mark, you shouldn't vote for yourself. Well, here we go. 20. That's enough for nice. Okay, what do you expect from today's session? And that one is a typing question. So what we got is a tag cloud here. Let's see. Rainbow colored, I hope. Oh well, I don't know. Oh, okay. Drop me a call. Surprise is also a nice one. So we would surprise them if we come up with unicorns and beer, I guess. Great. Oops. Oh, okay. Okay, I captured the expert. Guess it is neat. Great. Learn something, new knowledge, I hope. A better overview. Let's see if we can make that. And we are for sure nice people. Nobody is having a deal with that, is it? Almost 20, so 3 more. And we go to next slide. 18. One is left. Let's go. Okay, let's see what we have sort of job roles here. Yeah, it gives us the opportunity to understand on what language we can talk to them, right? Mm-hmm. Yeah. Look, ex project leader is funny. Okay, I guess that one is the job, looking for a job, right? As you might know, we will gonna share later on themes, right? Yes. Sorry. Next time I'll be better prepared. Great. 18, and it looks like all in IT, architects, some engineers, bunch of developers. Cool. wait. Oh, 21 response. Happened now. The that's the unicorn coming. 22. Okay. Uh, an all-terrain talent. I've questioned that into the chat. Maybe we can get in. Okay, cool. Yeah. Yes, for sure. So, remind you folks out there, if you have a question, don't hesitate and use the chat. We're monitoring the chat all the time so that we can gonna keep on to response here as soon as possible. And if a question is very relaying to the content or related to the content, we will put it on and talk about that. So let's move on. Last question, or I guess it's I like that folks are really keen about the digits watching us. Great, okay. Looks like. Yes, you're right. That's an important thing. Subscribe to this channel, please. That supports us. Let's see. 22 is for us now enough. And that question is for the end of this meeting. And folks out there, please make some noise. Use Twitter, LinkedIn, whatever. Use the hashtag AzureDevMook and or tag us with AzureDevMook. Let us know if you're happy with it. Share with others that you've seen some cool stuff today on our YouTube channel or on our Meetup. And for sure, we're looking forward to see you face to face, hopefully sooner than later. Okay, let me come back to our Meetup's topic. And we warmly welcome Neno and Mark, whom are already commenting here, as you might get recognized of. They're coming up with a topic, Azure DevOps pipelines, and especially with builds and releases, and also agents and container builds. And after that, Martin and me are going to share some informations and hands-on with Azure DevOps and GitHub. and how to use infrastructure as code there. I hope that suits your needs, and we hope also that our content is that what you've expected for. And I would say that Nino or Mark will start with their session. Whom of you is going to share first? Great. So here we go. Okay, cool. Great. So then please share your screen while I will stop sharing mine. Yes, looks good. Okay, Nino and Mark, your stage. We will go on mute now. That check had to be done before. Oh yeah, got your idea. Okay. Give me some noise over there.
Give me some noise over there.
Okay,
We're testing
great.
audio.
Hello.
It looks like that the audio signal should now be there. Yep.
I guess that also means people were only able to hear Ralph speaking the whole time, I guess.
Oh,
Oh,
interesting.
my fault. I'm doing that the second time, so streaming using.
Now,
Okay,
somebody says
now.
now. That's good.
Okay, great.
Fine now. Okay.
Okay.
So looks good. Then we will start all
Start
over.
over. Yeah.
Yeah. So again, a warm welcome from our side for our part all around Azure DevOps, Azure Pipeline, CI/CD automation, Docker integration, whatsoever. We thought about using this meetup as an AMA session. So ask me anything. We had a long day at the conference. We're in an answering mode. We have had hundreds of questions regarding Azure DevOps. So we would like to do this session as interactively as possible. So please use the chat, ask us your question, and we try to provide you all the answer you are asking for instead of just go through our standard presentation. So this is the idea. Hopefully the chat fills now with questions and we just pick the first one. Right, Nino?
That's exactly right. We're so glad to be here. We have been answering all day already, so it's the perfect time for more questions. And no, but seriously, the Azure DevOps is a very large product. It has been based on Microsoft software that is now 14 or more years old. So you can do a lot of things with it. And we have done like 5-day trainings, and we have not been able to cover half of the features that Azure DevOps has these days. So we have to focus on something. So Mark and I are both specializing in Azure DevOps, which used to be Team Foundation Server, and it had a few other names before, like Visual Studio Team Services and Visual Studio Online, it was called some time ago. And the main service out of the set of services within Azure DevOps is certainly the automation part, which is Azure Pipelines. So you can automate builds, you can automate your deployments, you can build code, but you can also just deploy a piece of infrastructure, as you already heard in the intro. So that's what we are specializing in. So I think we should frame the discussion, all the questions you might have now, specifically to this automation part. And I will open up Notepad, and we will start collecting your topics, because it's really your time. I mean, it's your precious time this evening. So let's use it wisely. Let's not just do a basic presentation. Many of you said you're using it on a daily basis already. So that's definitely a good sign to do more question-based approach today. So I will open up Notepad. Mark, you are watching the chat window,
Yeah,
hopefully.
I'm watching it.
I will also open up already one of our test instances, so we have something to look at hopefully soon. Oh boy, login is always the fun part.
So what we learned today, I didn't know that, the name of this dog we're seeing. This was a #1 question in our session. What's the name of this dog in the login page or in the Azure DevOps page?
Right, there are lots of dogs. I never realized actually there are lots of dog pictures, like comics in Azure DevOps. I don't know why, and I felt embarrassed when somebody asked me today what the name of that dog is, and I didn't know. So we really have to come up with an answer to that question. Maybe it's a real dog that somebody at Microsoft has. We have to find out. Anyway, so yeah, so it's a pipeline, and the whole pipelines thing has two main concepts. There are builds and there are releases, and then you have agents or containers that run those pipelines, and that's the stage for your questions. Now, I see the first questions are coming in, so let me go back to Notepad and save Notepad. Not that Notepad ever crashed before, but it's always good to save something. Agenda, Meetup, Azure Dev, MOOC. Okay, our agenda for today. Keep it coming.
Okay, we have a question about the default agent, maybe default queue. So let's talk a little bit about agent organization, how we organize them, how we use them, how we select them, etc.
So yeah, okay, agents specifically, like organizing agents. All right. What else?
So we have another question. Is it possible to populate the list dynamically for custom pipeline parameters, like you are able to select a list of branches?
Okay, that's a very specific one, right? So I assume it's YAML based and it's dynamically, let's say dynamic parameters, which means dynamically populated. Well,
exactly.
I mean, that's an easy one, right? I think the answer is no right now. So I think it's a very easy one, but.
Yeah, let's still talk a little bit about it. And we also have a YAML question about what about the branching and the YAML files?
All right. Live on. So yeah, that's new, right? YAML files are new. Builds used to be defined by clicking, and now the new thing is that you put it into a text file, which happens to be YAML, and you get lots of advantages out of that. And there are a few things to consider here, especially if you have multiple repositories, maybe. So that's something we might talk about here.
Okay, any more questions so far?
Well, that will be an easy and short evening today.
Yeah, but maybe let's start with those questions.
Let me add one more. Let me add one more. I think we have to talk about builds versus releases at some point, because that confuses people a lot. I mean, both is something like a job that executes on an agent. Both can trigger the same tasks and run the same tasks, and yet they are very different, and usually they are differently defined. So I think we have to talk about this.
Let's quickly add another question regarding YAML for builds and releases. So what about the current state? Where can I use YAML, where not? What's the new world also for release management or release automation when we use YAML?
All right. I added this. Oh, good. Any more question, anybody? Like, especially the ones from you who are using Azure DevOps on a daily basis. Is there, you have no questions left? You're using it, you're happy with it? Are you using like everything? Are you using just part of it? There's one question coming in.
Okay, a wiki question. So basically, how about writing documentation in the repo, and am I able to display it in the wiki? So it's first about writing documentation and then showing or integrating it in the wiki.
Yeah, that's a nice thing. We should show that. I mean, it has nothing directly to do with pipelines, but I think it's something that many teams are looking for. So it's definitely good to show that. And it's a feature that not everybody knows exists. Cool. I hope we will get more questions during the course.
That's
awesome.
great. So priorities are okay. Should we start with agent, Nino?
Let me think about where we should start. Shall we start showing a YAML file before we do anything else?
Yeah, why not? Why not? Let's show the new world, and then we could dive into the first questions.
Alrighty.
So let's open up a standard YAML file, standard build, and then we can talk about the structure, about the details, and go back to the questions then.
Sure. So we've done lots of decisions here already, right? So this is our demo account, and it started with, we created one Azure DevOps organization, and we really recommend you only have one Azure DevOps recommendation. It will only get complicated if you have two. Even within that, try to stick to one team project. Even if you're doing like hundreds of projects, it's still very often a clever idea to stay within one project, because that project, or team project as it's called, they didn't really mean a project or a team. They meant something super big. Let's call it a large container. And within that large container, you can create stuff like repositories, you can create your teams, you can create your work items, and you can organize on sub-levels of that team project. So what we've prepared here is a repository. As you know, one project can have multiple repositories. One can be version control, classic version control, check-in, check-out, and you can have as many as you like, which are using Git. So this is what we have here. This is a Git repository. We chose the approach of a larger Git repository, so we didn't create like thousands of Git repos. We put everything that we need into one repository. And that's our first step that we always recommend. Whatever you need later for this application, be it the database, be it the tests, be it whatever, like the documentation, put it in this repository. Actually, we even have a docs folder because somebody asked where to put the docs. We can show that later. So that's so far for the code. And of course, we used the latest feature set from pipelines. So we created a build, and we did that by creating a YAML file, not by clicking. And this is our YAML file. Mark, this is your favorite part. Do you want to talk about this file, and I can go up and down and show things?
Yeah, definitely. I can start. So I'm assuming most of you know the YAML syntax, etc. But just let's get it started. So YAML is the new standard, and we have some, how should I say that? Not a very good UI editor. We have some helpers writing YAML for us. So whenever you're working in that YAML file, if you go to a task which is in the editor, I'm sorry, Nino, I'm pushing you through.
No worries, I'm opening it in the editor.
Yeah, but
there
if we talk about YAML, I think we should quickly talk about the UI support in YAML. So if you open the YAML file in the code editor, nothing happens. If you open the YAML file here in the pipeline editor, you have some helper UIs. So you notice that basically, if you scroll down a little bit, Nino, that we get to a task.
You have no tasks in here.
I'm sorry. There's a slide head-up display saying configure, which opens the tasks board on the right hand side. And you can actually edit all the parameters of this task and override existing YAML definition, or just use this task helper to add new tasks. So if you're not familiar with all the details, want to look at the task, what properties can I set, this is a nice helper. There is also another possibility, and I don't know how many of you know that, there's actually a plugin for VS Code you can use to get some IntelliSense for the YAML files to edit with. So you have tool support, but it's like source code. You have to know what you're doing, and you're basically editing a text file. So I'm sorry for that short excursion. Let's go back to the YAML file you originally wanted to show.
Yeah, let's
Nino?
maybe summarize what we already said. I mean, so Microsoft is now focusing on this new YAML standard. I mean, YAML is not new, but defining a pipeline in YAML is new for Microsoft. It has been around for quite a while on the service, on the cloud service. If you still happen to use DevOps Server, which used to be TFS, then you just got a small subset of the YAML features. You don't have everything yet. You will get more with the next update of Azure DevOps Server. And you start organizing your pipelines in files. Now, those files can be pretty long and ugly. And this is the reason why you didn't find any task in this file, because we use templates, basically multiple YAML files, to split up this very long and deep process. Now, this nice editor that we've just shown you has a lot of nice features. If you would have tasks or you want to insert tasks here, you can just use this toolbox on the right, and it's so easy to do things. And that only works for your main YAML file. So the actual work right now that we have to do is back in the normal repository text editor. So that's not cool, but that's the way it is right now. So Microsoft is still building a lots of functionality for those YAML builds. Some more things in general about Azure pipelines. I know it's called Azure pipelines, but actually what they wanted to say is something like a general job execution engine. So just because it's named Azure doesn't mean that you cannot install it on premises. Just because it has Azure in the name does not mean that you cannot deploy to anything else. You can deploy to AWS, you can deploy to Google Cloud, you can certainly deploy to Azure, and you can run whatever you want. The question will only be like, is there a task that I can use that's already there? Or do I have to figure out the parameters and invoke like a compiler or a special tool I want to use? I've seen in the chat somebody asked about Terraform. Can I use it instead? Of course you can. And now only the question is, will I figure out how to invoke Terraform myself, or will I search if there's a Terraform task that I can just download and use within my Azure Pipelines thing?
Come
Okay,
on.
nevertheless, let's go back to
Don't unfeel so much Terraform stuff.
No, I'm not stealing away. I'm just saying that whatever you want to do, it's not limited to anything. You can ask like, does it support eggs? And the answer is yes. And another thing will always be the question, do I want to rely on a task that I downloaded, or do I want to invoke the command line myself? Maybe. That's all I would say about Terraform. No worries.
Yeah. So yeah, let's go back to this YAML file, and especially to the Git repository. So you see, we placed all our files here in the Git repository, and this leads me to the first question. What about branching and those YAML files? Where should they reside? Is it master only? The answer is quite easy. No. Every branch you're working with has those pipeline files with it. The big advantage of using YAML pipelines is that the pipeline basically evolves together with your code. If you're working in a feature branch, you add some new resources, you need to change the deployment process, add those things to your pipeline in this specific feature branch. Build it, test it, have a look if it works out, correct it, and then you, with the pull request, basically, you're not only integrating the application code, but you're also integrating the automation code you need to deploy those new features. So it's really not a question about, is it only there or there? It's like code. Whenever you branch, all the files go with you. So in every feature branch, you should extend those YAML files with your feature extension that they're compliant to your new deployment. So this is basically the answer to the question, where does it live? It lives everywhere. It lives in div, in Git, and wherever you're branching, wherever you're changing, if it affects the pipeline, you do it in the same branch and integrate it in the same pull request as you integrate the code.
All right.
Okay, so let's go quickly now in a little bit into those YAML files. So what we see here, the normal structure of a YAML file is we have some management or configuration stuff. Like we see here, we have trigger definitions, we have variable definitions, and a very special thing here is there's a small caveat. So actually, you can override those kind of things when you're in the pipeline editor. So basically what you do when you create a new pipeline in Azure DevOps, you're basically writing this YAML file. But there is also an entry in the database saying, hey, there's a new pipeline and it uses this YAML file. So in this editor, you are able to override variables or to override some triggers. So this is the only thing you can actually do outside of the YAML file. Everything else is in there, and the question is, why is it needed? So for example, if you have some secret variables, where do you put it? It doesn't make sense to put your secret variables in the source code, which is indexed by the search engine, and you're basically are able to just search for passwords, etc. So you would add them, for example, as secret variables, and then during runtime, the variables defined in the YAML together with the variables defined on the pipeline definition are combined, and then the pipeline is executed. So those are the two special parts in this pipeline definition. Besides that, let's quickly go on a very high level through it. We have, besides variables, we can name it, etc. And then we start with the actual control structure. So what you could do in YAML is you can just have an easier way of it and basically just start with steps. So what you do in the easiest way is you're executing a list of steps. So this is the easiest way of defining some automation. Here we see jobs, and we could also see stages when you if you enable the preview features. So basically what they built into this YAML structure is the YAML structure is capable of doing a full deployment with multiple stages, which contain multiple jobs and then contain multiple steps. So this is the structure. And if you don't use multiple stages, you just leave them. If you don't use multiple jobs, you just have the steps in it. Important to know is that the job always runs on an agent. So when a job is executed, it gets sent to an agent, and that agent executes these jobs. So what you can parallelize is you could execute multiple jobs in parallel, or you can also execute them in a sequence. But important to know is the relation of agent and the corresponding execution is this job we're seeing here. And then inside a job, we have one or more steps, which are tasks, which could be pre-built task from Azure DevOps, could be task from the marketplace, or as Neno already told you, the easiest way is to just set up a script task like PowerShell core, Bash, CMD, whatever. This is really the low-level automation you can do with it.
Okay, Mark, this looks all highly configurable. So it's almost a programming language, right? I mean, I can invoke files, I have variables, I have parameters, I have expressions, I can have if statements in there and all that stuff. So I can build whatever I want. I can build it on Windows, on Linux, on Mac OS if I wanted to. So I have to know still how to build stuff, right? If I'm doing .NET Core, I need to know what my tools are and what order to invoke them. Like, if I do NPM, I need to know what's important there. But in theory, I can build whatever. So if a new developer comes up and he says, I've done something in Go, I heard that like people under 30 are using Go these days. I have never used it before. Maybe I should look at Go. I don't know. But like you can just do it, right? It's not bound to any Microsoft technology specifically. You can even just copy files if you want, or version your PowerShell scripts if you wanted to and copy them somewhere. Mark, how about we have a look at how this is all coming together, how this looks on runtime? I mean, we've seen we have YAML files, and I talked about that we have a bunch of YAML files in split up. But let's get this to action. I mean, where do we need the build process? We need it maybe for daily build, maybe for a CI trigger. But what I know you like most on Git is the ability to have feature branches, which are temporary of their nature, create a pull request when you're done. The pull request will trigger a pipeline, which will build all this stuff. And if you wanted to, it can also trigger a deployment, which is a separate pipeline. And if this all comes together and it's green, then we can merge back to master. And that allows us to use a single branch strategy. So we don't need to have develop if we don't need to, or any other branches. We have master and we start working on feature branches. Shall we just do this?
I think so.
All right, where do we start?
Okay, so let's have a quick run. So you mean you want to show the PR integration, or you want to first of all show that the pipeline definition?
Let's do a change. Let's do a typical day of a developer. Let's do a change, create a feature branch. When we're done, we would create a pull request. Maybe we have to double check the pull request settings real quick before we start. But
yeah,
otherwise,
so
you can choose where to start.
Let's quickly check or start with the Git repository with the policies. So the first thing I want to do, if we have a
but I don't want to show
branching,
the policies, right? I mean, people shall be surprised by my policies. So I need to be very quick and just tweak them a little bit. And we will see what happens when we turn them on, right? Let's go to the policies page real quick and just do some more clicking here because I prepared a few things. Yes, indeed. Thank you. Save. Okay, we're done. We can work now. So this is what the admin will do once. And now I'm just a user. Where should I pick up my work? What do you suggest?
Okay. So there are multiple things, but normally we plan it. We do some HL stuff. So there should be a task or a PBI somewhere, and this should be our starting point normally. So yeah, unbelievable but true. We have some work items here. Let's just pick one we want to work with. A bug.
Let's get a new one.
Did you ever had a bug in your life?
No, I never had bugs. This is just for demos. In real life, I don't do bugs.
Okay, so what I could do basically is I have a look at the bug and open Visual Studio, VS Code, whatever, create a feature branch and so on. Here, we want to start a little bit differently. So please open the work item.
Maybe first add you because you have to do the work.
Thanks. And on the right-hand side, technical debt, all the bad things.
All the bad things.
Yeah. On the right-hand side, we see information regarding deployment and development. So all those developer-related tasks and also the overview, what's the state of this feature I developed, are visible in this work item. So if we start from the work item, we're able to get a full traceability of whatever we do. So instead of just creating the branch in Git, it's a really normal way to do it normally, we could start in the work item and create a feature branch from within the work item with a big benefit that from now on, when we work with that branch, everything is tracked against it. So I do not have to bother about assigning the right work items, creating the release notes that this bug is fixed, etc. Which tests do we need to run? Because if we set up the traceability inside that a bug references a requirement, the requirement is referenced by a test case, and so on, by simply creating the feature branch out of the work item, we start this traceability and have all information combined. So let's just hit create branch then,
Yep, there's a link here. Click on it. And here we go.
Set a branch name. Any preferences?
I could put in the work item number.
Yeah.
Something is broken, or maybe fix something is broken, not break something. Fix something is broken. So that will be the name of the new branch. The branch will already be created from master, already be connected to work item 626. Let's create the branch. Here we are. Now, typically, we would obviously clone this repository to our workspace, in our computer, open Visual Studio Code, whatever we work with, and do all the work there. Now for the demo, we will just do it here on the website in this experience. Shall I break something or shall I just do some random stuff? What do you think, Mark?
Break something.
Break something? Seriously?
Yeah.
Okay, then let's look at the code then. Code is up here. Pages. I need more room. Let's break stuff. Error? Error is always good. Let's delete some random stuff.
Great. So what would have happened if you didn't do that on the feature branch, Nino?
So if I would try to change anything on master, because master is protected, this is what my administrator has configured before we started this demo, I would not have been able to check in. There would have been a commit error message telling me you have to use a pull request workflow to do any changes on master. So we're protecting master from low quality. We really want to keep master deployable and buildable at all time. So this is why we force people to work on other branches, ideally on temporary branches, which are often referred to as feature or topic branches. All
okay.
right.
So we did something, and
Yep.
now let's try to integrate it. So
Let's
what
go
do
to
I
pull
do?
requests. Let's create a pull request. Let's find a nice name for the pull request. Hopefully fixed the bug 626. Something is broken. Now I don't have to put in the number in here because, as you know, the branch is already associated with work item 626. I'm just doing that for reference here, but I can see it down here that it's already referenced internally by the system. We have a description to fill out. So I've done a few commits and I've used some description when I checked in, a commit message, but I wasn't very careful there. So now is a second opportunity to think about, okay, what did I exactly change? Is there anything specific about the way how I solved the problem? So stuff I really want to have preserved for the next years so people can find out if this change did something crazy or why I have decided to go the one way and not the other. This is something I would do in this description here. And as you can see, we also have a template, like a default text that shows up, and we can just fill it out or delete it if we don't want to. We can also ignore it, it's allowed, but it helps you keep a consistent look and feel here. Any reviewers, I can add people that need to review, and I can have a look about all things that changed, and we've done 2 changes in 2 files. Let's create this. Now here we are in the pull request. So the pull request is now open, and we need to make sure that the quality is high enough that we allow this code change, or this sum of code changes actually, to move over to the master branch. And on the right, you can see all the policies that my administrator defined. Those policies can be required, and those policies, some of them can be optional. In this case, we only have required policies. There is one policy that doesn't show up here, and that policy is it has to be mergeable, right? If there's a merge conflict, there's nothing the system can do. It will just say there's a merge conflict and you have to fix it on your own using Git on your hard disk and so on. And now, since we don't have a merge conflict, nobody else has worked on master, we can see that a few policies are already done. So the first one is somebody needs to approve this change, and this is not yet okay. We need to link a work item. This has happened. All comments need to be resolved. We have no comments yet, so there's nothing to resolve right now. The build should obviously work. It automatically triggered a new build pipeline, which was written in YAML. The build pipeline now failed, and I think I know why it fails. Let me close a few windows. So let's have a look. Oh, everything's red. That's also very nice. Like there's one compilation error, and I see 5 error messages, and one of them is hopefully helpful. Yeah, that's the one.
Yeah, the first one.
Yep.
But you have to feel bad if you're doing such a mistake. So this is why they put 5 messages on it.
It's probably a good thing. I agree. The more of red, the better. I agree. It will also show up warnings, but in this case, I don't have warnings. I only have real errors. Okay, I can still fix this, right? We're working on a feature branch. So although the pull request is working, it's easy to make changes. I just open up the branch in my favorite editor or directly here. and I just have to figure out where I did my changes. Pages. I think this was the error file, and this is, I think, the most important change. I need to edit it first. Fixed build break. I can also associate another work item if I wanted to, like if I have a bunch of tasks which are very detailed, I can also select them from this list or just put in the ID. But I don't do this now because I think it's enough to connect a pull request with the actual like user story or bug, why I'm doing things. And I'm not going down on the task level where every step is documented. So if we look at the right side, we still have a work item, no comments. The build is queued, so the next free available build agent will pick up this job and hopefully verify that our code change is now okay. While this is happening, let's start reviewing things. So we can have a look at all the files that changed. We can see what changed in those files. We can.
You corrected that one. Why
Yeah,
is it
I'm
showing?
just showing update 1. So we did another check-in afterwards, right? And pushed it. So that would be update 2. And with update 2, we have, yeah, this one it changed. And if you combine both, we only have one change left.
Yep.
So I was still looking at update 1, and that's an old version. You're absolutely right. Anyway, so if you have this, or like we can go to all updates, so we see the final result, and we don't like something we see, we can actually click on it and start commenting. I think this looks bad. Please fix. I can also say who needs to fix this. This guy.
Me.
I don't know who that is. If you've never used this before, I don't know if you have. This is very developer friendly. So everything a developer needs has been integrated by Microsoft. So Microsoft has a full team working on social things. Social things are things that developers like. Something like pizza is very important. Some developers like coffee. I heard bugs are important, or a bomb, very important. I think there's fire too. Yeah. So all the important things are there. Best part, you can actually answer your own questions. So if you don't have anyone to talk to, you can talk to yourself. And if there's nobody who actually likes what you're doing, you can even like your own posts. Yes, Microsoft has a full team working on features like this on Azure DevOps to make it feel more social. Good. What else do we want to do? We now have comments. You can actually see this here at the top that we have one unresolved comment still open. And we said that this is an important thing. So it's actually a required policy here on the right. So we cannot finish this pull request without not actually answering and dealing with that new thread of discussion. So somebody has to come down here and answer it and click reply and resolve, or change the status here to one of the last 3 states, like resolved, won't fix, or just closed. And now by closing this, I signal to the system, yes, I've dealt with the feedback. I've done something here. Thank you. So what has happened meanwhile? The build is still running, I think. Let's have a look at how the build looks like. The build is still running, and we can see here that this build has 3 things going on. Those are 3 jobs. We can see that one job, yeah, they're running in parallel apparently, because like the second one is already done. The first one is still running. You can see that it's spinning a little bit. And the last one has like a clock. So this has not yet started. It's queuing. So those seem to run in parallel. The SQL Server one was very fast, 18 seconds. It's a small database. The compilation takes longer. And the last job seems to wait for one of the other, or actually both. In this case, it's actually both. It's waiting for both to finish, and then it will execute what it has to do. So this is what Mark was referring to when he showed you the structure of the YAML file. So you structure it, first of all, in jobs. And usually you would use jobs if you have something that has to run on separate machines. In our case, we needed a special machine, a Windows machine, to build a SQL database because we're using tools that only run on Windows. And for the ASP.NET Core application, we could easily use a Linux file or a Docker container, and this is what we've actually done. And if we click on any of them, you can see what really happened, and you will see all the tasks executed by this job on this machine. So again, every job executes on a different agent. Here you see that we chose the hosted agent. Hosted agent means Microsoft is running, configuring, and doing everything with this agent. So we don't have to care. We get, I think, 30 hours for free per month to use this agent. If it's more, we have to pay, or we have to go and use our own self-installed agents. We will talk about agents in a moment. Now, if you look at all those tasks that are executed here, this is what we have defined in our YAML file. The only thing that happens automatically is the first one, like initialize, of course, but then this one, it's called checkout. So the system is checking out the source code by default into a temporary folder, and that's where the automation stops. And now it expects us to write the right YAML for the technology we're using. So everything behind here is what we defined. We came up with that idea to do it. In our case, it's .NET Core. So you see .NET Restore, .NET Build, .NET Test, and a few other things, .NET Publish. And we do run some PowerShell scripts. What's also important about a build pipeline, that typically a build pipeline will end with at least one publish artifact task. Why is it necessary? Because this is a temporary machine, an agent provided by Microsoft. It will delete the temporary folder at some point. And if you want to reuse those files created here, for example, because you want to deploy them later using a release pipeline, then you have to put them somewhere. And this is why you use publish artifact. If we go back and look at this main window here, we can see that the whole build took 3 minutes. This is the version we have built. It's actually a pull request validation, the pull request ID. And we can see that it published 6 artifacts. Now we could have used just one artifact and call it the output. That would have been perfectly fine. But it's a good idea to have lots of artifacts, because now we can more granularly define where we want to download which artifact, because those artifacts are needed on different machines. So the web app needs to go to our web server, the database needs to go to the database server, the functional tests, which are UI tests, they need to run on a test machine that has a browser installed. So, and those files can be very big at some point. So why download everything on every machine? So this is why we ended up creating 6 artifacts for separate things. And there's nothing else than files in there. The web app is just a zip file. The tests are just a bunch of DLLs. Deployment scripts actually has a PowerShell script and some other files. The database is a DLL that's actually in a DECpack file. So that actually comes out of the SQL Server data tools, which help you deploy and version the schema of a SQL Server database. Not so much the data, but it helps you a lot with the schema and schema changes and deployment of that. Okay, long story short, this is the YAML file you have been seeing a few moments ago, just executed the execution view that every developer sees. We do have tests in here, not a lot, so we try to create it, make a real example, so it's real life. So if you go to the test tab, you will see we only have one test. It's 100% successful. We run it for 4 seconds. Yeah. And we got this trophy because we're so good. Hooray, there are no test failures. And yeah, there's this one. It's actually a real unit test. It's not even empty. I don't know if you know, but if you write an empty unit test in .NET, it's actually a green successful unit test. I always liked that. So what did Microsoft think about this? Like, it's not crashing, so it has to be kind of good. It could have been worse or something. I don't know what they thought about it. Doesn't matter. That's what you get from the build screen. And not to forget, we started this whole thing actually from a pull request, from pull request 153. So here we're back at the pull request. We're still waiting to approve this pull request. And now the build has succeeded. The build is green. That's cool. I like that. We're still waiting for an approver, and we're waiting for something else here, which is called a release.
I think this release thing, normally people don't know that why there is a release in the policies, because normally you don't get a UI supporting it, or it's not that obvious on how to get a release on the PR validation.
Yeah, you have to know a few things, like what is a release pipeline compared to a build pipeline, and then how do I actually add this as a required policy, which is really some hassle to get it to show up here. It should, in theory, start at some point automatically. I don't know why it's not started yet. But what we're trying to do here is basically not just stop here with a green build, because the green build only has one test. So we don't even know if the quality of this build is good. We know it compiles. It could have been worse, but we don't know if it's good enough. We want to run at least one end-to-end test. In this case, it's a website. So we want to run a UI test in a browser to see it's actually starting up, it's opening up. And that's something we did not put in the build. We could have put that in a build as a separate job, no problem. But in the past, we had to split this out in a separate release pipeline. And we kind of still like the idea of putting it into a separate release pipeline. So Mark, shall we have a look at this release pipeline first?
Yeah, maybe I just want to add a couple of few words to it. So you thought about, yeah, we want to verify it, we want to deploy it and do some real testing on it. But there's another benefit from using a release pipeline in peer validation. Think of it, you have a product owner and he also needs to approve. So basically in our mainline branching model, whenever we approve this PR, it will be integrated into master. So why not also using the whole deployment automation to set up a PR specific environment? I can send the link to the product owner. He can actually use the application because it's deployed, can click through it, provide you any feedback, and also approve the PR from his point of view, not a technical way, but yeah, it's really what I wanted you to do. I can click it, I can see it. So this is another benefit of deploying the PR state into an environment as we do now.
Absolutely. Speaking of which, I see in the chat we got a few comments about specific technologies like, how can I do Xcode or whatever I have locally running already, and how can I figure out what the right commands are? This is really super specific to your technology, what you want to do. Luckily, Microsoft had a good day and they've written a few documents. So if you go to docs.microsoft.com and look for Azure pipelines, they have a bunch of examples for, let's say, the most typical 10, 12 different kinds of applications. So you will find a tutorial for Xcode, for Xamarin, for JavaScript, node-based, whatever you want to do as a very good starting point. And they will actually show you the YAML which you might use. You have to fine tweak it anyway, but it's a really good start because the templates that you use when you just create a new pipeline here in the system, they're not as good as the documentation. So in this case, documentation is better than the templates. So definitely have a look. Also, another question like about on the Mac agent. So yes, as I mentioned already, there's a Windows, there's Linux, and there's Mac agents already available hosted by Microsoft. However, the Mac agents, they're only available in the US. So you can still use them even if your Azure DevOps is running in Western Europe, so Amsterdam data center. But it will definitely copy your source code over to the US to compile because they don't have Mac agents here in Europe. It's always good to know if you have any legal issues in this regard. Okay, Mark, shall we have a look at the releases? We never showed our release pipeline.
Yes, let's do so.
And then maybe we can talk a little bit about the difference between build and release pipeline and why it's still a graphical designer. Do you want to go ahead?
Yeah. So basically, first of all, what's the difference? So both of them use the same technology. It's the same agent. You could run the same task basically in a release or a build. So why do we have that? So what we already showed you is the build is the one baking the pizza, if you would like so. And then there's a delivery guy bringing the pizza to your home. So this is what the release does. It already takes a baked pizza, it's already there, there's an artifact, and it only cares about shipping it. So it's all about deployment automation. And for deployment automation, we have some special requirements like, where should we put it? There could be multiple stages like a feature branch or PR stage, like a quality assurance stage, like a production or pre-production stage before. So we have staging requirements. And in addition to that, even though we already tested it during CI builds, something could fail. So we still want to run some automated tests, but maybe we have some manual actions involved. So there is a clear need for providing some approval functionality. Maybe there's some manual testing needed. So the test manager would manually approve it to say, yeah, I tested it, I did some explorative testing. Or maybe before we go live, there is also some manager approving the go live. So there is another functionality. So it's the same technology used down below, but on the user interface level, we need some new functionality to decide how we deliver it and if you're allowed to deliver the application. So the big difference here is this is not YAML what we're seeing. So the whole release management is currently not available in YAML. There is a preview already available, multi-stage YAML builds. You can enable it and you can already play around with it, but there are still some features missing we normally need in an enterprise environment for release management or release automation. So this is why officially, if you're doing release automation, you go to the classic release, as they're called, which is the classic UI you already knew from the classic builds, and we can click through it and define it. The structure beneath it, it's the same. We have stages, we have jobs inside stages, inside the jobs, we have the tasks running. So all those things are the same thing, but just with another UI. So yeah, let's have a look at it, Nino. Just open it.
Yeah, right. So I already clicked on the release menu item on the left, right? So we've been in pipelines before. This is where our builds are. And as Mark mentioned, pipelines can also have multiple stages these days, but they cannot replace this release functionality right now. So you click on the rocket icon on the left. I mean, the pipeline's rocket, then the releases rocket. Then you select your release pipeline, you go to edit, and you will see that you get a nice visual editor. So the bad news is it's not YAML, it's not versioned the way that you would expect with your build process as part of your branch and your repository, but it's a nice visualization. And you can see that we have 3 stages here, and it looks all a little bit different. And maybe, Mark, you can tell us what we see here and why things are the way they are.
Okay, so we learned that there is already a guy baking the pizza. So this is what we see on the left-hand side.
That's a build, right?
We need something to deliver. So we have artifacts. Here we define the input artifacts for our release pipeline. So normally we mostly have one artifact, which means it's a build output normally. The build output consists of multiple artifacts, pipeline artifacts, as we have seen before, but we could add another artifact like, yeah, we need the build output and we need this script from the Git repository, or we have something in TFVC, or yeah, just open the 5 more artifacts type that we see what we could use. So we see we could use something from Azure Artifacts, from GitHub, Docker Hub, etc. So we can just say, what's the input to start the release definition with? So
that release part, that means is so universal, so generic that you can use it with the new build system, with the old build system. Even if you don't use Azure pipelines, you can connect it directly to GitHub or some other things in here. There are even some more plugins which don't show up right now that you can add, so you get more of these input artifacts. So that's a very, very generic, universal piece of this whole system. And you can combine it with everything you need. And if you think you need source code right in here, you can grab it right in here and not even need a build. However, mostly for software development, as Mark mentioned, we stick with one input, which is the build. The build produced everything we need, and parallel jobs created everything. And now we're consuming this in all the stages we will draw on the right.
Yeah. So what's special about that? So normally, if you're talking about staging, everybody answers like, yeah, it's this dev, test, production. But actually, it's not, because what's this dev? Could a dev version really go into production? We actually want to validate the development version. And how do we do that? Yeah, we are creating pull requests. We are working on a feature branch. So what we see here is that there's no way, if you basically run the dev stage, there is no way of getting dead artifacts into pre-prod and prod. It's really a switch. Are you going to dev or are you going to production?
Well, especially because we're using feature branches, right? So
Yes.
we're looking like, okay, what do we do with stuff from feature branches, which is not yet on master? And then a total different question is, what shall we do with code that made it to our master branch, and what happens next, right?
So if they pass the quality gates through the PR, it's integrated in the master branch, so they're allowed to go to production. So how did we do that? So what we basically did, we're filtering the artifacts we get on the left-hand side and say, okay, tell me where you're coming from. What's your source branch or originating from? If you're originating from a feature branch, let's show it. So we have here artifact filters defined. And if you open them, we see that basically 2 branches are allowed. So it's not 2 branches, it's with wildcards. So every feature branch or every refs pull branch can be integrated. So let's quickly have a quick chat about what's refs pull. So if you're building a pull request, the goal of the pull request is to validate your code when it is merged into master. So this specific branch in a pull request build, it's nothing else than a merge branch between your feature branch and the target branch. So in our case, it's master with a merged feature branch, and they're building it. So if you want to publish or deploy this feature branch, we actually have this as a boundary, that the origin of the artifact is this merge branch from the pull request. In addition to that, you already showed it, there is another pull request trigger. So it's not enough to just say, yeah, allow this branch. We really want to use this particular stage for pull requests. So they really make sure that if a pull request is triggering a release automation, we are really making sure that only specific stages can be deployed with, because they could contain errors, etc. So here we have to activate pull request deployment as well in order to be able to put our pull request artifacts into this stage.
All right, let me just double check if, the pull request trigger is not even turned on. That's always cool. Let me just use this and trigger it for master. Now the automation. So I was wondering why it didn't trigger automatically, but we turned off the triggers on the artifact on the very left.
Yeah.
And so that's the reason why it didn't trigger. Okay, so we've looked at the dev stage now. So this is triggering for the pull request. That's the stuff we were coming from. But maybe you can give us a short preview about the other 2 stages and how they, how the dependency is and what happens when code arrives here. When does it arrive here?
Yeah. So if we're originating from master branch, we're allowed to go to production, but it would be a bad idea to just directly publish or deploy to production, because production is a little bit different, especially if you have large databases, etc. So we still want to make sure it is fully working. So what we are doing here in a pre-production environment, we do a full deployment just in a pre-production stage or environment and running all the functional tests against it. With big databases, etc., we also normally do something like, yeah, let's get a backup of the production one and deploy it for the pre-prod to see if there is any problem with existing data with for our new features, etc. So it's very dependent on the project, but normally we have some pre-production stage to really verify everything completely before it's really deployed to production. So maybe let's just open this pre-prod stage, Nino, to give a little bit of insights of what we're doing. So what we see here is we basically have 2 jobs executing. First job, we see a deployment job, which is doing the basic things like, is there an Azure web app? So we have configuration as code with an ARM template here. So we deploy this ARM template saying, yeah, we need a database, we need a web app, etc. And then we're doing some little transforms for the app settings. So normally with different stages, you have different connection strings, you have different settings. So you're basically transforming your settings according to that stage. This is what we are doing in file transform, applying all the variables for this particular stage. Then we deploy the the web application in this case. We're using this out-of-the-box Azure Web App deployment task. And very important, we are not just deploying it, we're also doing a first deployment verification or smoke test. We just want to make sure that it was deployed, that something is listening, that there's a response, and this is why we're running a smoke test here, just to verify the deployment succeeded. If that is okay, we have a fully deployed environment. So the second phase is about testing. What we show here is UI tests. So we prepared a different VM. It's running an agent in interactive mode. So this means it can execute or interact with user interfaces. And what we do here, since it's a web application, we're using Selenium test automation and just click through the website, making sure everything is up and running, the right data is shown, and we do some UI tests in order to be sure it's really working as it should be. Okay. Nino?
Yep.
Oh, okay, yeah.
You happy?
I'm happy.
All right, let's go back to the pull request then. So this is everything that should happen, you said. I think there's one more thing to point out about those release pipelines, that usually, or very often, I see that release pipelines are not fully automated. You know, people still want some manual testing or still want some manual deployment and not like fully automated of every check-in or so. So we can do this, and we've actually done this here. So we have here at the very beginning and here at the very beginning, we see that we can define so-called pre-deployment approvals. We could also define post-deployment approvals, but that's a different thing. So for example, on a test environment, maybe we say, okay, we'll deploy to the test environment, and afterwards somebody from the test team has to approve it. And for a prod environment, it makes more sense to have a pre-deployment condition, a pre-deployment approval, so somebody has to approve it before it goes out. And we can definitely do this and configure this here. This is shown very nicely. And if we go back, I think we even had a pipeline. The last one here, it's stuck in pre-prod. It's waiting. Let me do this here. It's stuck in pre-prod. It wants to go to prod, but it's pending on an approval from either me or Mark. So I can define who's approving it. When they approve it, they get an email notification so they can come online and click yes. And you can even approve it and approve it for a certain time. So I can say, yes, let's approve it, but let's defer it to tomorrow morning when the developers are in the office. I don't want to have this going out at night. Or maybe I want to do this at night, depending on what you're trying to do here, right? Okay, so if we go back to our pull request where all of this started, and if we're lucky, no, the release has not been triggered. That was all because I had this trigger turned off, the important trigger turned off. Let me manually help this a little bit. Let's start a release from the build that just verified our code. Let's go the normal way from here. Release 26 was created. And now let's see what's happening. So on the left, as you know, this is the artifact. This is our build. And we have built our software for a pull request. You can see that it's a pull request because it starts with refs, pull, and a number. And since it's a pull request, it will trigger dev. It cannot go into pre-prod because the conditions are not met. So it can also not go to prod, but it can go in the development environment. Now, this environment in our case, we only have one because we're a small team. If you have a larger team, you need to make sure that this is a dynamic environment. So if you're using Azure, for example, you would dynamically spin up a new test environment, maybe even an own resource group with everything you need to test. So it's definitely easier if you have unlimited test environments. And if you have a limitation here, you have to come up with a clever idea who may use this and who doesn't. All right, we can just wait here and watch, or we can click on logs, which is more the developer-friendly view. You see all the log outputs from the build server. It's like the build, just it's running something different. It's the same task used here that the YAML builds know about. And that is it. We are still waiting for this because that's almost the last policy we need to finally have our bug fixed and proven that the quality is where we want it to be, so that we can integrate and merge back to master. There's one more thing missing. It's a approval is missing. And I think I can self-approve in this case because my settings allow for self-approvals. So the only thing still we're waiting for is the release now. And once this is done, we can finish or complete this pull request. Now, what's interesting, you have to manually complete a pull request. I don't know why this feature exists at all, Mark. Do you use manually or do you do set autocomplete? Mark, do you have any recommendations?
Oh, sorry, I was muted. Normally, if everything looks fine and just the builds are missing, I set autocomplete because I don't want to go back and spend time again. So if everything looks fine and there's just some agent time missing, I set it to autocomplete.
Okay, so let's do this, right? I will set autocomplete. So everything we're waiting for should now ideally be the release and hopefully a green release. What is this dialogue all about? I mean, this is now stuff that I'm usually asked when I finish a pull request. And one thing I have to choose here, besides, you know, the title, the description, I can still tweak them one more time, is this merge types here. Can you comment on this? Why is this important? And can I just do everything or?
Yeah, as we obviously see, we can't do everything because we have a lot of forbidden stuff in it. Why do we have forbidden stuff here? It's because we defined it. So you see it's forbidden by policy. So like our administrator told us, yeah, it's not allowed to directly push to master branch. We are also not allowed to merge in a way we want. Our administrator told us you're only allowed to squash commit your changes. So you can argue for hours what's the best strategy of integrating pull requests. I really like the squash commit here because you're basically having a very, very clean Git history. Everything is still available in PR, but everything you did, all those little commits, all the typos, etc., everything gets squashed together with a single commit on master branch, of course, with a reference to the PR with all the details, but so with this merge type squash commit, you really end up with a very clean master branch. If you don't want to do that, you're fine. You can do a merge commit and seeing all the details, all the detailed commits of the PR, or you could do a rebase, etc. So our recommendation or my personal favorite is really the squash commit because I do have to pay attention only one time in this dialogue and everything else gets squashed. Okay, so now if the release is okay, everything will be integrated and we finished it. So to recap that a little bit is what we did is we used the pipeline automation with the YAML pipeline as well as the release pipelines as a quality gate for our source code. So we used a fully blown pipeline to validate the changes in a PR, and only then if the pipeline, the build, and the release is okay, we're allowed to integrate the code. So basically now nothing should happen if we deploy to master or to production because everything has been deployed, everything has been tested. We're good to go and confident that we're able to go in to production. So Neno, I suggest let's have a quick look at the questions we had at the beginning.
I don't know about you guys, but I need a beer and I need it quickly. So I think it's a good opportunity since we're waiting for this release to make a short break. We will definitely look through the questions list and update our agenda. I saw that there were a few questions like release notes. It's a very interesting one. We should not forget about that. There was one about dependencies on the task board we should add. But maybe we can do a short break, come back with beer and even more questions, hopefully. And then we will see how this looks like when it's finished. What do our organizers think about this?
Well, for us is that's pretty fine. Pretty fine. Already the pause screen is on, and I'm gonna have a short break, and we'll be right back here for you. Thanks for watching. Don't miss to subscribe.
in
So,
English.
here we are back again. Thanks for waiting and sticking with us. And we go further with the topic of Nano and Mark. And here you go. Thanks a lot for waiting.
Yeah, welcome back from our side as well. So we're still waiting for the release.
Yeah, so
Seems a
we're
little bit
back, but
low.
the release is not back, right? It's still doing its break. No, it's not
Yeah.
doing a break. It's probably deploying. I can click on it if you want to have a look what it's actually doing.
It's working somehow.
It probably is. I mean, we're doing a lot of things,
Yeah,
and
UI
especially
tests.
UI tests. There's a certain amount of time to set up a new agent, boot the agent, run a UI test. And our UI tests run just for a few seconds, but the whole setting up of an agent takes time. Same thing for the infrastructure deployment that we do. I think you will hear more about deployments of Azure Resource Manager template files and everything today, but that's a part that takes a while. But we're close. UI tests are running. I think that's one of the last ones.
Since we know it's probably going to be green, should we just recap the
How do you know that this will be green? You never know until the test is telling you. And especially,
I know it's programming, but I'm very confident it's going to be green.
I'm not, and I want proof. I want a video that this is actually working. Video.
Okay, so show me the video.
So everything's green, it says. I don't know if this is true. Let's click on the, well, actually, let's go one. So we're done here, right? It's completed. It has done the merge, everything as we told it. So we're done. We can go off the screen. This screen, this pull request will live forever. It's not going away. You cannot delete it. Even the branch is now deleted, but this screen will remain, including all the discussions, the approvals, the test results. So this is something for your archive. And it will now move to, if you go to pull requests, it now moved to completed pull requests. This is where you can find all your pull request discussions and decisions and whatever happened. So you can find out why things happen. So you might remember when we started all this off, we started from our boards view where we had this bug. And the bug was somewhere here. It's now gone. Where is it gone? There it is.
Nano, in between, is there,
Yep.
There was a very nice question in the chat. It was related to the release pipeline. The question is there any way to automate release throughout the pipeline?
That is an awesome question. We will answer it in a moment because it's not an easy question. It's a good question, though. It's I think one of the top 5 questions we get for release pipelines. And in short, the information is there. You can even view it on the screen. But if you want to automatically create release notes, you actually have to write some code or integrate some task that does it for you. But anyway, we'll go back to this question in a second. So what you see here now is our work item 626, the bug we worked on today. And the bug is now done. And I have not manually put it into done. It is done so automatically by the pull request. Because we had it connected to our branch and we closed the pull request, this connection here was made and the state was changed. Also, notice here on the right, we have from the bottom, we see this is the merge commit on master. So the master branch tells me this code has arrived on master. I can also see this is the pull request that merged the code onto master. So I can click here to go into the pull request details. And then there was a build run from master, and I can see the build that is run here. So I get all the information connected to my work items. This is the reason why so many companies are using work items, not because the Azure boards feature is so nice, but because it's nicely integrated with all the other parts and you can figure out what you've done later. So this triggered a release to pre-prod. Actually, the pre-prod release failed, so this is not a good one to show. It's a good one to show if you want to see how error messages look like. But so this was our dev unit test that we've run, no, the UI test that we've run. And I told Mark that I want to see proof. So I want to go to the attachment tab and I want to open the screen capture Windows Media file. So we do have video recording and screenshots running. And I just have to download it. Oh, there it is. So if you configure it correctly, you will get a video proof. This is your agent waiting for commands. And in a few seconds, it will open up a browser window run the commands we've put in there, and tell us if the test is correct. This is going super fast. I might need to stop the video. It's opening the browser. It's just going to the website, checking that the text is there, the page title's okay, and removes everything. So you can run UI tests during night for hours, and you can have this video as proof that the tests have been run and that it all looks good. Now I'm done and we can go back to the questions.
Okay, thanks a lot for proving me the correct results.
We definitely need proof. Nothing will be accepted without proof here anymore. This is why we automate things. We go back to the pull requests before we go back to the question list. Okay, we received the question about release notes. Here we go. So Mark, what shall we talk about? Shall we go from the top?
Yeah, I think so. Let's go quickly through it. So there was a question, how do I define YAML pipeline as my default agent? So actually, what you're not able to do is really say that agent. What you can do is you can provide a default pool where a couple of agents may reside. And you can also define demands for that agent. So basically, I demand some capabilities, but there is no real agent. Of course, you could do, say, I have a demand, the agent needs to be named 1, 2, 3, whatever, and there's only one agent with that name, obviously, and so you select the agent. But normally, you just specify your demands and the default pool, and then the best match and the first match of this filter criteria is used for running the job. So what you can do additionally is you have different hierarchies of defining it. So you could define a pool for your whole pipeline, and then specific for a job, choose another pool for that job because you need to run them on, I don't know, on a Windows machine, the rest runs on Linux, and so on. So this is what you can do to actually select or define the agents you're using in the pipeline.
Okay, that means we have a YAML file, a pipeline, and that pipeline, as you said, consists of jobs. Each job can use the same or a different agent pool. And in that agent pool, we have one or more or n agents. And if you want a specific agent, you don't say the name. Otherwise, what you can do is use a demand and say something like, I want the one that has, I don't know, install shield installed is 1. Like, or that has my code certificate installed is 1. So you can use demands to figure out which agent, if it has to be this one agent. Otherwise, it would just grab the first available agent out of this pool. And there is something called the default pool. So if you're just lazy or you just started your project, there is an empty default pool, but you have to register at least one agent within that pool before you can use the default pool. All right, I think you talked about the branches and where they should live.
That.
Right. Dynamic parameters, I think that refers to a very new feature that, when you start a YAML pipeline, you can override things. And the question was if you can dynamically populate this. This is so brand new that I think the answer is easy and it's a no. That's the reality. We talked about build versus releases. We also learned that the releases are mostly non-YAML. They're visual. And we learned that builds are mostly YAML. So they're two different worlds, but nicely connected together. And both are here to stay for a while. Both have different advantages and disadvantages, and they work great together. So we talked about the current state of YAML. Maybe interesting to point out, if you're using DevOps Server, YAML is available in 2019. It got a few updates in 2019.update 1. And it will get a more significant update for multi-stage YAML files in 2020. So that's the versions you want to have installed if you want to handle YAML pipelines. 2 things left, Mark. What do you want to start with?
Yeah, let's stay in the release. So release notes. But
right.
you almost answered it. So it's a very famous question. So all the data, if you did it right, is already there. So what does this mean? What happens in a build? So every build is checking the change set, so the commits in case of Git, and compares it to the last successful build. So we know the difference, all the commits, and if you mention your work items inside the commits, it's quite easy to just read that data and say, okay, those were the changes, those were the associated work items, this happened in this build. The same thing does happen for releases. The release does the same thing. So you are basically looking at a stage and saying, okay, what was the last successful deployment to that stage? How many builds in between? So get all the change sets from all those builds in between and provide the information. So this is what you're able to access through the API and also through the UI. So the change sets are already generated for you. And the only thing which is missing is what do you do with that data? You generate a PDF? Do you publish a wiki page? I don't know. Do you send an email with it? Whatever you do. And because of that situation that this is so specific to the teams, there is no generic solution. So there is the data, there is an API, you can access the data. So please program your stuff you want to do with the release notes. I don't know, generate a PDF or add some wiki pages with it.
Yeah, I mean, every company has this problem. It's one of the most asked questions for release pipelines or Azure pipelines in general. And there are two ways how you can solve this for your company. We already told you that there's nothing really built in other than a few views, and you have to figure out which way you like more. So what you see here is our release, and the release failed, but it doesn't matter. It was going to release on this pre-prod environment. And you can see here in this next to the summary that we have the commits. So the commits is basically the delta, what happened on the branch in the source code between the last time a deployment was made to this stage. So this stage, this pre-prod stage is comparing with the last deployment on the pre-prod stage. You could even change the baseline for this comparison and say, okay, give me all the work items which changed since release 17. Not every release was actually deployed to pre-prod, so I can only select the relevant ones. And since they know the commits and the commits have an association to work items, I can see, okay, what's new? And in our case, what's new? It's the bug that we hopefully fixed. So that's what you get. That's the information you would need for release notes if you want to build them up from code. And now you have to do something with that data, write it somewhere, put it somewhere, show it somewhere. Now, that's one way how companies and teams like to do this from the source code based. What's good about this, it's the truth, right? You made a code change. You said this is what you've done. It travels through your build. It travels through your release. And the code knows this has been done. Another way to do release notes, what other people do who are doing Scrum, for example, they don't do it at the code level at all. They go to work items. They look at their boards and all their stuff here. Maybe they create their own query, and they will query for give me all the work that has finished this sprint and now is in the state of done. And they just export this list that they generate after they say, give me everything that's done. And only if the iteration path is sprint 1. Now, probably my sprint is empty. Oh no, I have 2 things in my sprint. That's good. Something's broken. That's cool. And now I can right click and open in Excel. So now I have release notes just based on my work, and it has nothing to do with code. Maybe somebody just said it's done and it's not done. But now this is purely based on the task management system. And maybe it has more tasks in there which are not code related, but still worth mentioning in the release notes. Those are the 2 ways to do it. I hope this is asked, or like the ask is done with this. If you have more questions, let us know. Mark, how about Wiki?
Yeah, so first thing to note, it's about documentation. And
right.
So normally the requirement for documentation is it should be coupled to the code changes. So if you change a feature, you add something, you also expand the documentation, change the documentation accordingly. So it makes sense that this documentation resides in the same Git repository, that it gets branched with PR validation, integrated into master, that the code and the documentation has the same state. So this is first thing. So normally what you do, you just add a docs folder or whatever to the Git repository, and you just work on that. What I don't like to do with source code integration is to work with Word files, etc., because they are treated as binary files, so they're not mergeable. You could have conflicts or overwrite something. So if you really want to work with Word, etc., use SharePoint. You can merge that there. So if you're really writing technical documentation, normally you use Markdown in the repository. So everything which is Markdown enabled can be automatically displayed in or rendered in Azure DevOps, also for Wiki. So what we know that is that Wiki is a special Git repository which just contains those wiki pages, markdown pages, and pictures. But there's also a way to point to a folder of another source code repository and show that in Wiki. Maybe you can quickly show that. So you select publish code as Wiki. You choose the right Wiki, the right Git repository, and here, yeah, let's choose the branch, and then you can select the folder. So if it's a code repository, you have this docs folder in here, and we just want to show the content of this folder as wiki pages. Okay, so this is the definition, and if we do it, it shows us our documentation as wiki.
And I prepared that already. So what you see here actually is the wiki representation of that folder we've seen a moment ago. Let's go back to the folder real quick. That's the boring docs folder. It's full with MD, with markdown files, so very simple text files with a little markdown. It also has a secret file, a .order file, because it's not alphabetically. I can actually move things up and down in the order. And I'm not modifying those files at all here in the source control view anymore, although I could, especially on their hard disk, I could do it. And instead, I'm doing everything here in the Wiki UI. It looks nicer. It has what you see is what you get. Well, it's almost what you see is what you get. You can edit, and you edit on the left, and you see the preview on the right. So it's not really what you see is what you get, but it's the best you can get right now as a Markdown editing experience in the browser from Microsoft these days. What's nice about this is, since this is just source code, kind of, it's my part of my repository, I can do full text searching, I can do branching, everything that you know and love from source code. I can go revert to older versions and all that stuff. Clone it on my hard disk, use a real editor if I prefer that. I hope this is the one thing you mentioned today, right, Mark, in your session during the Microsoft Virtual Training Week?
Yes.
Because that was the question was about your session today. Basically.
Okay. Sorry. I didn't.
Finally, we get to demo this. So hopefully this is what I think it was Marcus expected, and that he's a little bit happy with. So from experience, it really depends on who you're talking to. If somebody's used to use Microsoft Word for documentation, they will hate this. They just are not okay to write this kind of syntax, you know, the markdown syntax, although it's very easy, but that's too much for them. They think it's ugly. They cannot imagine how this will look like later. So it's hard to convince people which are Word-based. For developers, it's great. It's easy to read. Okay, I think we're done with this one. There's one last question that we got to for Azure boards, totally unrelated, but I'm happy to answer it. And once we're done, we should talk a little bit about Docker before we go to the other cool stuff, which is deploying your infrastructure. So there's one question about dependencies on the board. I think we got this question during the day today. And boards. So work items, which are all those little tiny cards here, and they're bug work items, user story work items, feature work items, issue work items, and whatsoever. Those work items are in a relationship to each other. So there's the typical relationship of a hierarchy, and you can actually see the hierarchy, for example, on the backlog. And there are two other forms of relationships, and one of them is a dependency. So basically, this task has to be done before the next task can start. And while you can have this relationship between work items, which is good, it does not show in any of the views. So you will not see it here on the board that maybe one of these items requires another one to be finished first. It's not shown here. So you have to figure out a way to maybe change the priority or mark it somehow that this cannot start. It's blocked because it's waiting for the other one. So Microsoft has not found a way to show dependencies on the board. It does not seem to be important enough for them. It's also an industry problem. Like if you have multiple boards, how do you show relationship from this board to a different board for work that is planned for the next sprint? It's not that easy to show, but right now it's not shown at all on the default boards. That said, there are a few extensions on the marketplace that do deal with dependencies between tasks and items, but I have not tried them out personally yet. So we're done with the official agenda unless we have container questions or Mark wants to tell us a few things about container builds. You officially have 4 minutes, so I'm really keen to know what is the most important takeaway you always wanted to tell us about container builds.
Okay, so I think let's do it the other way around. Is normally in these days you can get confused about all the possibilities you have with container builds, because there is this container and you can use that as an artifact for the runtime. You could use it as a build environment. You could also place the agent inside a container. So there are many things you could actually use the containers for. So in my opinion, first of all, there are two scenarios. Do I just want to use containers as a build environment and just, I don't know, compile a WinForms and that's it? Or do I really want to use container as a delivery? So I package everything of my application inside a container. I have the full environment, the full runtime of my application with a container, and I'm delivering this container image to the target platform. So those are the two things, both supported in Azure DevOps. So the cool new thing is the container jobs. So we learned that everything runs in a job. So an agent runs a job, and now there's this new functionality about container jobs. So what's the difference? If you use a container job, you define a Docker container. What happens during runtime? The image is pulled and the container is started. So you don't need any agent in the Docker container for container job. So what happens actually is it's like docking the agent to the container instance. So what happens actually, everything you do in your build tasks or in your pipeline tasks is all the commands are actually executed inside this Docker container. So you're not inside, but all your commands, all your definition of your YAML file, everything is executed inside this container. So the big benefit is you version your build environments with containers, you reference the container image. So you have your YAML file in Git, and you also have the reference of your container in Git. And this leads the pipeline to pull the requested image from your container registry. So you have a fully blown versioned CI environment with all the SDKs, with all the operating system dependencies. Everything is versioned. This is the cool new feature we get with Container Job. And if the container is up and running and has all your tools, the only thing you have to change is one line. You just say container double colon and define your image, and all the tasks are running inside your container. So it's pretty easy to go with. And there is a little bit more of an extension, and I'm really looking forward to what we are able to do. So is besides this container job, there is also functionality for service containers. So whatever you need for example, for integration testing, you could start additional containers. And what Azure DevOps is doing, or Azure Pipelines, is building a full environment with a Docker network for all the communication, all the isolation. So you can spin up a huge environment with multiple databases, storage, application servers running to just test your application in the pipeline. So those are the new cool features with Docker and Azure pipelines. And I always used my 4 minutes. So is there anything very important you want to ask me now? You've got 20 seconds.
I have never seen anyone explain it that fast.
Yeah,
Not
I
too
tried
bad.
my best. So I'm used. Normally, Nano uses all the time, and I've got 4 minutes left for my 1 hour presentation. So I'm used to that.
Okay,
All
folks.
right,
I
all
guess the
right.
question will be: will we have those two guys once more on our meetup? And I guess the answer is yes, we have to, because you hadn't had enough time to speak. No problem
Yeah.
and issue for us.
Yeah, we come back for sure. Yeah, let's do just a container topic. So we've got enough time, and if people are interested, we could also an additional one for showing Azure Container Services together with Azure DevOps for all the deployment scenarios for
Oh,
zero
wow.
downtime deployments, etc.
What a cool idea. So we're gonna have a Azure DevOps Series session 3 with you and AKS and container image pipelines. That's awesome.
Yeah.
Woohoo.
Ooh. Okay, so Nano, if you could stop sharing right now.
I hate to stop sharing.
Oh well,
Complicates you.
I'm so sorry.
I know you are.
Okay,
There
here
we
we
go.
go. Thanks for being back. Martin, it's up to you. Next slot. Gonna have fun with you for 20, 30 minutes. What about that? Are you ready?
I'm ready. Sure.
Ready, prepped. Okay. Please.
Okay,
Yeah,
thanks
Nano.
everybody. We're out then, right?
Thanks,
Okay.
Mark.
Thanks,
Yeah.
Mark. Thanks,
Thank you. Have a
Nano.
good one.
Bye,
Bye
guys.
bye.
Thanks a
Okay.
lot.
Thanks. Bye. Talk
care,
to you.
everyone.
Take care.
Okay, can you see my screen already?
Your screen is online and
Perfect.
it's your stage. Have fun, Martin.
Thank you. Okay, so hi everyone. So Nano and Mark gave us a very good overview of Azure DevOps. Now I want to give you a brief introduction about GitHub Actions, and I want to show you how we can use GitHub Actions to provision resources in Azure. Before I start, let me quickly introduce myself. My name is Martin Brandl. I'm working as a cloud solution architect at White Duck, where I'm also the head of our cloud operations and cloud development team. If you want to contact me, feel free to reach me via Twitter or LinkedIn. I do also have a blog where I post some Azure-related content. So if you want to check it out, you will also find an article there that will cover this topic a little bit deeper. Okay, so this is the agenda for today. I will start with a very small GitHub Action introduction, where I will cover the very basics of GitHub Actions. Then I want to show you how we can establish a connection between your Azure resources and your GitHub Action workflows. I do also have a demo prepared where we will provision some resources to Azure. And finally, I hope we will have time for some questions. Okay, so what is GitHub Actions? GitHub Actions allows you to automate basically any kind of process you have within your software development project. Probably the most famous example is the continuous integration and continuous delivery process, where you build your application and deploy it through any target system. But it can be anything else too, like you can, for example, create a ticket on a third-party CRM anytime someone creates an issue within your GitHub repository, for example. So just any process you want to automate. GitHub Actions gets executed based on an event that happens, for example, inside GitHub, like if someone pushes code to my repository. Or you can schedule GitHub Actions and say, for example, my GitHub action should run every day at midnight. Then similar as we saw in Azure DevOps, there are a set of hosted runner available for every major operating system like Windows, Linux, and macOS. And you also have the possibility to add your own self-hosted runner where you have more control over the installed hardware and software, of course. Then GitHub Actions comes with a built-in encrypted secret store. This is the place where we usually put all our credentials that are necessary for things like service connection to third-party applications. And finally, GitHub Actions are easy to write and easy to share due to the good marketplace integration. Okay, GitHub Actions are described as workflows. And a workflow is basically just a file that is written in YAML and is always located within the .github/workflows directory. The structure of a workflow is very simple. It contains one or multiple jobs. And one concept which is very important here is that each job will run on a separate environment. So why is this important? Because you won't be able to share state between jobs using the file system. But within a job, you have one or multiple steps, and these steps runs on the same agent, so you will be able to share information between the file system. I think that's the only most important part here to know. And finally, steps are a collection of actions, which are the smallest building block of a workflow. And an action represents an individual task, like, for example, the invocation of a PowerShell script, or as we can see here in the screenshot, the run of a CLI to build your application, for example. On the top, we can also see the trigger of the workflow. And on the next slide, we will see what kind of triggers are available. Basically, there are 3 types of events that can trigger a workflow. The first type is anything GitHub internal, like if someone raises an issue, or if someone writes a comment, or even if someone forks our repository, we can trigger our workflows. We can also define that our workflow gets triggered based on a schedule, which uses the cron syntax, as you can see in the screenshot. And finally, if we want our workflow to get executed based on any event that happens outside of GitHub, we have the possibility to use a webhook, or it's just an API call and invoke the workflow ourselves. Okay, then one thing I really, really like about GitHub Actions is are the community-powered workflows. Why? Because I think this will be the successor of GitHub Actions. GitHub Actions is kind of new, but there are already over 3,500 GitHub Actions available in the marketplace, which, by the way, is over 3 times more than Azure DevOps has. And Azure DevOps is out there for years. So I expect to find a workflow for almost any process I can imagine within the marketplace soon. And that's why I believe that GitHub Actions is the future of software automation. By the way, if you want to create your own action, you have 2 options to do that. The first one is using is writing the action based on JavaScript, which I would say is the native approach. And you're also able to write containerized actions. So basically, you have these 2 options. Both comes with pros and cons. A few words about pricing. GitHub Actions are completely free with unlimited build minutes, at least for public repositories. If you want to use GitHub Actions on private repository, you will have at least 2,000 free build minutes available. And depending on your license, you have up to 50,000 minutes, free build minutes available. But of course, you always have the option to buy additional hosted runner minutes. And as you can see in the picture here, the price is depending on the operating system. The macOS agent is 10 times more expensive than the Linux one. If you want to add self-hosted runner, they are completely free here. Okay, now let's talk about how we can connect GitHub Actions with Azure. So in Azure DevOps, there is a separate place where you can create so-called service connections to any external or remote services like Azure, for example. And then you are able to use these service connections within your pipeline. In GitHub Actions, you store the connection information within the GitHub secret store, and then you reference them within your workflows. So I think under the hood, both will work the same, but the naming is a little bit different here. Also, the user experience within Azure DevOps is much better in my opinion, because Azure DevOps has a graphical user interface where you can select your target source or target system, and then it asks you for the information that are needed to create a connection. And in GitHub, you just have a text field where you have to paste your credentials. And you have to know what format, which action needs the credentials. But for the Azure DevOps part, or for the Azure part, you do have two options to authenticate to Azure. The first one is using a service principal. This is the most common, and I would say the recommended way to authenticate to Azure. For those who do not know what a service principal is, you probably know what a user principal is. Like my user principal in our tenant is martin.brandl@whiteduck.de. And together with my password, I'm able to log in with my account. And so a user principal represents a person, but as you can imagine, I do not want the GitHub action runner to run with my account. So there's another concept which is called a service principal that represents an application. And the name of the service principal is called the client ID, sometimes the application ID. And the password is called the client secret. And with these two pairs together, an application is able to log into Azure and has an identity which I can grant access to and allow them, for example, to deploy to a resource group in Azure, which we will see later. And the second option is the use of a publishing profile. A publishing profile is basically just an XML file that contains some connection information and also gives you access to specific Azure resources. When I started working with Azure many years ago, there was no resource manager available, and the authentication using a publishing profile was very common. But nowadays, I would not use it, and I would definitely go with the first option. Okay, but I think that was enough slides, so let's go with a demo. And I have to share another screen now. Okay. So what we see here is a almost empty GitHub repository. I only added two files. The first one is the README file, where I described some prerequisites for the demo. So if you want to do the demo yourself, I hope I provided enough information that you are able to do that. I also added a cleanup part to ensure everything is clean after the demo. And the second file, what I have here is an ARM template. This represents Azure infrastructure, or let's say this is the infrastructure as code approach native for Microsoft. And in this example, I will deploy two resources. One is a web app, which is usually used for websites, for example, or to deploy an API. And the second resource is an app service plan. The app service plan is needed because within Azure, every web app has to live inside an app service plan. But the content within this template isn't that relevant. It could be a much more complicated example for sure, but then the demo would also take longer. So it's not about the content here. Okay, so we have our deployment file. Now what we need in Azure is a resource group, because within the resource manager, every resource in Azure lives inside a resource group. And as we can see here, the subscription is empty. So we need to create a resource group. And we also need to create a service principal that we will give access to the resource group in order that our workflow can deploy resources to it. And for that, I have a little PowerShell script, which I will just execute and then explain, just to save some time. The first thing it will do is it will create a resource group named GitHub Action Demo Resource Group. inside Germany West Central. And then it will create a service principal with the name here and grants it the contributor right to the resource group we just created. With using this switch here, we tell the Azure CLI to get an output that we can reuse for to authenticate against Azure, and that we can see the output here. It's a JSON which contains the client ID and the client secret, which basically represents the username and password of a service principal. So I have to copy this part here now, and I have to create a GitHub Actions where we paste the credentials. And the secret store is available within the settings module under secrets. Here we can add a new secret, paste our content, and we choose a value. Almost all demos are using Azure credentials, so I will stick to that. Okay, and now we have set up our, I will call it service connection, like in Azure DevOps, or at least we have our credentials available here. And let's check whether the resource group got created. Yes, that worked. And we will also check whether we have gave our access. Yeah, okay, so and our service principal has contributor rights to this resource group. So it should be able to provision resources in here. Now it's time to create an action, and this can be done using the actions module here. And we won't choose any predefined workflow. We will just set up it ourselves. And this is how the editor of GitHub Actions looks like. The first thing we need to do here is we can choose a different name for the workflow file at least, but I will stick to main YAML. But I do want to give the workflow a little bit better name. Let's call it deploy to Azure. Then we have to define the trigger and choose the event which causes our workflow to get executed. Right now, it will get executed on every push or pull request to the master branch. I think we can omit the pull request trigger, but I don't want our deployment to get executed every time someone just changes a line of code in the README file or something like that. So let's further restrict it to the Azure deploy JSON. So only if someone changes something within our infrastructure as code template, then this workflow should run. Then this sample contains only one job, which is called build right now. I will change it to deploy because it fits a little bit better what we want to do. And right now it runs on a Linux agent, which I'm fine with. Then we have 3 actions within our sample here. The first action will check out our repository and make it available inside our runner, so that we are able to access the files. And this one is very important because we want to deploy an ARM template that sits inside our repository. We will need this this action, and that's why I will leave it. That's probably a common pitfall, I think. If you want to deploy something with GitHub Actions, ensure you have the checkout action in place. Otherwise, you won't be able to access file within your repository. And these other actions are just hello world outputs. We can safely remove them. Okay, now the first thing we need to do is we need to log in, or we need to authenticate against Azure. And to do so, there is an action that is called Azure Login within the marketplace. And if we click there, we can copy the necessary part in our clipboard, paste it here. Then we have to ensure we use the right amount of spaces because it's YAML. And something I missed telling you is how the structure of an action itself. So an action can contain a name. If you omit it, it will use this string here in the output. But if you want a more user-friendly output, you should give it a name. And this concept is very important to know. You reference an action using the GitHub account name, then the repository, and then you can reference a release or a tagged release. Just to show you what I mean, if we go to the Azure login action repository, we see this action lives within the Azure account. This is this part here. Then it's the login repository we are referring to. And I expect a release with this tag inside the repository. So let's go to release. And yes, we are basically, this action basically references these assets here. So that's the concept behind the actions, and that's why it's so easy to write our own actions. You just need a public repository, and everybody can use it. Okay, then within the with section, we can supply some parameters that this action requires. And for the login action, we need to specify our credentials that we put into the secret store, and we can reference them using $ double curly bracket secrets dot, and then the name of the secret we chose, which was Azure credentials. And the second parameter is optional. We don't need it because we do not need a connection to PowerShell. So now we have a login, or we have authenticate to Azure. The last thing we need to do is to use our template and deploy it to Azure. And to do this, there are basically two options. And when I started playing around with GitHub Actions, I tried to write different workflows for use cases I face in my daily business. And I was surprised that there was no, let's say, dedicated Azure Resource Manager template action available within GitHub. So I decided to write my own, and I will use this now. The other option would be to use the Azure CLI action, but this would require us to know exactly which kind of CLI command we have to use, and also which parameter is they require. So I want to go with the Azure Resource Manager. So with this task here, we also copy it to the clipboard, paste it here. And we also have to supply some parameters. The first one is the name of the resource group we want the template to get deployed, which is called GitHub Actions Demo resource group. Then we have to specify the template location. It's Azure deploy JSON. Then optional, we can choose the deployment mode. I will leave it with incremental, so we can just delete this one. Then we can choose a deployment name. To get a better output on Azure, I just provide a name here. And now we can provide parameters for the Azure Resource Manager template. And we have to check the template very quick. And indeed, this template requires two parameters. The first one is the name of the app service plan, and the second one is the name of the web app. So let's provide the parameters here. I will go with GitHub Actions Demo ASP for app service plan, and web app name equals GitHub Actions Demo app. Okay, this should be it. That should be the whole workflow we need to deploy the resources. So let's commit the files. Or the file. And because we restricted the trigger to only get executed if someone within the Azure deploy JSON changed, we also have to edit it here. Maybe we add a dot here, description. Commit changes. Okay, and if we go back to our repository, we should see the dot here indicates that an action runs now. And if we click there, we see it's the deploy to Azure action. And the first job that will run is the deploy job. Right now we are in a queue because we are using the free hosted agent. It can take a few seconds before the job will actually run, but let's go and check where we are. Okay, so it already started running. The first action already executed, so we have all our files available within the agent. The login was also successfully, and now the last action runs, which deploys the resources to Azure, and we can cross-check that. If we go to deployments now, we should see them here. Accepted. This is, by the way, the name we supplied. I think it's good practice to choose a name, because then you see this deployment was executed by a GitHub action. And if you go there, we should see, hopefully soon, that the deployment will start and that our web app gets created. Let's go back there. It's funny, usually it just takes a few seconds, but okay, now. So now the app service plan gets created, and I see we get an error, service unavailable. No, okay. So the first resource should be there. Let's go to overview and refresh it.
As always, Martin, the demo god is with you.
Yeah, but I'm confident that this will run. No, not cancel. Refresh. Your deployment is complete, so it tells us everything is there, but it isn't. Okay, let's refresh the browser. The app service plan is there, but I'm missing the web app. Let's give it a sec. Funny.
I guess that one was the one with the arrow.
You might be right, but it should be still visible here. And no, it looks like our website also gets deployed. Okay, so let's go back, give it another try.
There it is.
Here it is. And we will be able to query the website, and we will see the default welcome page. Hey, app service developers, that Microsoft gave us here. And also, if we go back to our action, we see that it completed now. And yeah, that's basically all from my demo. Ralf, I would give it back to you.
Well, if there are no questions, and it looks like the chat is empty, there are no questions in. Let me check if there are some following us still.
Yeah, sure.
Oh yeah, well, there are 30 people outside and watching our video stream here. So looks like you've explained it very well, so that there are no open questions anymore.
Hopefully.
Yeah, cool thing, I guess. Okay, cool. Thanks a lot for demonstrating and having that cool issue with us, which is...
You're welcome.
That was really awesome to see it in action. Thanks a lot for that. Cool thing. So, last but not least, right? It's up to me.
It's up to you.
Okay. So, I'm gonna share a piece of infrastructure as code. First of all, few words about me. I'm a software developer and cloud solution architect. I'm almost 20 years in software development involved, and I'm working for a company called Double Slash. And if you want to reach out to me, hit me on Twitter at RARI2003. You got me there. LinkedIn also available, or you use our Azure Dev or Meetup group. And don't forget to subscribe to our video channel here. Okay, all about Azure and Terraform, and why this combination is so beautiful. It is like that HashiCorp invented Terraform just for being meant to be used with Azure. It's not true, I know that, but as you can see, and if you follow that link below, Microsoft is really sticking together with Terraform to deploy infrastructure as code. And if you want to get more about that combination, follow the links I'm sharing with you for now, because I'm just giving you a brief overview about Terraform. That we go into a Terraform script, and then we set up a pipeline, or we will see a pipeline and how it is set up, and then we will execute the pipeline and see the result of that. And at least the next thing is, if you want to use Terraform, the cool thing is that Azure CLI has that already implemented, as you can see here. And that means when you want to use Terraform with your toolset you're used to, for example, Visual Studio Code, just go and get your basket full of the Terraform extensions, which are available in the marketplace for Visual Studio Code. And it is not just Azure Terraform, there is also code highlighting available and all that stuff. Follow that link here, and you will get everything you need. And at least if you have that Terraform and you want to deploy that, you also can use that with Azure RM. So that means the resource manager of Azure is doing the job while you're scripting the job with Terraform. And that's really awesome, in my opinion. Now let's go on to the hands-on. So the overview of the Terraform structure and its dependencies will be shown first. Then we go into a Terraform script for an Azure Web App and we'll look onto it, how that's made. And then we go and see a YAML deployment pipeline in Azure DevOps, which is very similar to the one you've seen before, and but it is slightly different towards GitHub. Okay, that's for my short demo. The dependency for Terraform are a few things. I've mentioned already, if you want to use Visual Studio Code, you have to implement, or you have to download the extensions for Terraform, which I already did, and you can see that by those tiny logo of Terraform here. It indicates that Visual Studio Code has recognized that I'm using Terraform files in here. You also might see that the highlighted stuff here is red colored, and that indicates also that Visual Studio Code is able to highlight coding with Terraform. So let's see what's in here. First of all, let's see about the structure. As you might recognize, we have two folders, one environment folder that's separated also into dev. Then we have a module, and within the Terraform folder, you have a main TF and variables TF. That's how a common structure of Terraform looks like. So now with the main TF, you define your Terraform deployment. First of all, you define the Terraform agent itself. In this case, we're using this version of Terraform, and we're going to make use of Azure Resource Manager to deploy our stuff into Azure. So we define also some variables here to set our resource group name, the storage account name, and the container name, as well, like the key for the TF state. Then we define the provider a bit more, and we go and say which version we're going to use for. In this case, we use the version 2. And then we define a few more things which are necessary to get access to our Azure environment. The next thing is usually that you define resources which are common used by your project, like application insights. I've intended to do so because I want to show some slightly best practices. Beside that you can't use all of the code here for production environment for sure. So we set up this resource and we find that the resource name is provided by the Azure Resource module for Terraform. And within that, we give it a name and a suffix so that we can ensure that our environment is also tagged with a suffix like dev or integration or production or whatever you like. Then we define the resource location, which is the region in Azure if you deploy it in Azure. And for sure the resource group name, which is defined before, and what application type we're going to use for it. And also you can tag your environment. So I hope everybody is knowing the concept of tags within Azure. The next thing is that we define our resource group, which we've named before, a bit closer, because you have to have a place where you deploy your stuff. You also do that by defining the region, the suffix, and you can add tags here as well. Then you go and have the modules, which is, so that's a module. The resource group is a module itself. And then we have the weather check app service, which is a web API we're going to deploy. And that's also a module, and that's defined here. But it's also referring to be a module, which is here. The source is that one. Okay, that said, you might notice that we're using here variables. So the variables are defined here, and you're making the use of it by putting it here, and you can set also a default beside the description. So it is pretty like a parameters file with Azure Resource Manager. So you should be able to adopt that concept here as well. Okay, so far. Within the environment, we go and fill in the values for our variables we've defined before. So within this case, we're going to use dev as our environment tag and development as a tag, and suffix will be for all instances -dev. We've seen before in the main TF that we've defined the way Terraform is going to deploy our resources, and we have also defined our modules. Now, where are our modules defined closer? That's done here. Within the modules folder, we have the weather check, which was the place we've named to have the app inside. And there we go. So you see it's a bit more code than the 4 lines and before in the main TF. You have to set your application settings. For instance, the app insights key. You have to go and set identity if you want to make use of Azure Active Directory identities, service principal in that case. You have to choose the application plan for sure. Resource group name shall be tagged and so on. And within here, you go and define the app itself. So in that case, you give a name, location is set to the region we've defined before, also the resource group, and we're going to choose Windows as a execution server. Here you define the cost side of your app. In this case, we go and use S1 standard pricing. And there is the tag as well. Okay. The resource group has the same features, so you have to define the resource group within the TF, and you do that within the main TF as well. And you have there also outputs. So the outputs are used to be reused within your Terraform script. And as you've seen within the main as well, you're going to have here the variables which are defined here, and the same goes for the module of the application. Okay, that's everything. That's the magic of Terraform. if you're used to Azure Resource Manager, you'll be pretty easy joining into Terraform. And the nice thing is that when you use your standard editors, the most ones are supported with code highlighting and extension. Okay, so now we're going to use our dev environment to deploy that. First of all, this is our Git repository where we've put on all our files we've seen before in Visual Studio. And now we have to set up a pipeline using this Terraform script, right? Okay, let's go inside and let's see our pipeline. The first thing is we trigger just the master. We do not have any branches anymore, and we go and use a VM image provided by Azure DevOps, and then we go into the steps for our deployment. And usually with Terraform, you do a few steps before deploying, which means the same steps are going to be done here as well. So we define our agent, which is doing our Terraform script deployment. And as next step, we initialize that one. And there we have to set the Terraform state. So the state file is very important for when you deploy your stuff. And then if you have a change, you want to not to delete every resources and redeploy them. You just want to have the change and nothing more. And therefore, Terraform uses this state file here. So the next step is, we are in this, I'm sorry, wrong pipeline. Let's see. With Terraform, for sure, you can deploy your resources as well, which I will do after the demonstration. Okay, we go and use the Windows latest image, and we have the steps you might get used to while you are using YAML files as well. So it usually starts with an echo and stating what it is doing. You have the possibility to display your to give your step a name, a display name, which is useful when you have large scripts that you can see the following stuff down. And for sure, next step is initializing the agent. I've told you so already. There we go with the Terraform state as well. This one is the service connection we're going to use to access our Azure environment to deploy. And the next step is then to plan the deployment. That means Terraform is testing the script if it is runnable or not, and if all resources are deployable or and gives us a result back. And if that step fails, the deployment fails as well. And after that, we go and do a combine step. You can combine apply and the validate step. That one is pretty cool because usually you do that step by step for the first time in most cases. But at that stage, you can do that together because I guess you've done the apply and validation once before on your editor in your CLI. So we do that here as well, and we define our provider as well once again, and then we have the command options where we let the agent know on what he has to run and where to deploy it. Okay, that's the script. That's not a big deal, I guess, okay? Let's see if that runs. We go and execute the master and let it run. Pretty similar to GitHub, you have the possibility to see each step of your YAML file execution within Terraform, within Azure DevOps, and this is how it looks like. For the first time, it is waiting for an agent, which was faster at GitHub, and I don't know if Martin is using a paid account for it. Okay, let's see what happens. It'll take a while. Meanwhile, I'll show you my subscription, and you see that we do not have a Terraform anything resource group here. And in between, I show you also that we do not have a Terraform state file yet in. This is the place where it lays on, and it's not there. Okay, we're still waiting on it. Amazing. The whole world is deploying stuff. Okay. So here we go. Visualizing the job. That won't take long. Checking out Terraform. Here you see the title script, which was the display name we've decided to use within our Azure YAML pipeline description. And that's really a short one. Okay, so within the plan, I've told you, Terraform is checking the resources we go to deploy, right? So this is what it looks like. And it gives you a real cool overview about what it will do with the deployment. And let's see. Our Terraform file will be there. Oh yes, there we go. The Terraform file is in place. That happened right after the plan deployment. And now we go and see that our apply and validate step is going to provide our resources to Azure. Completed. And it says success. Let's see how a Terraform state file looks like. It has inside almost the things you have also defined within your Terraform file. And as you can see, the settings are there and some other stuff. That means that Terraform really knows what it has deployed before and will make the use out of it. The cool thing is I've just received an email that my deployment was successful. Let's have a look into Azure if it is true. Yes, here's the resource group. I've told you we're going to use the dash dev as a tag as well. And here we go. We have the app insights deployed and we have our app deployed as well. And let's go and see if that configuration setting towards our app insights instrumentation is in, and it is in. That's pretty cool, isn't it? So now what happens if we go and change slightly things within our weather app? And I've prepped here something. So let's go and use that one. And let's check that in. And I'm a bad guy. I'm not using any commit. And so I go and push that one. And since we've pushed it towards our repository and we've said that our pipeline shall listen to our repository, it shall be that it runs automatically. Stretch now. Did I push it? What the hell? Really? we're connected. Oh, I don't. Okay, great. I have to do that online. No big deal. Go into modules, weather check. You have, click on edit. You do not have that nice GUI here. But same functionality. And commit it. And hopefully our pipeline is going. And it is running. That's okay. Let's have a look into it. I've said before, our plan job is looking for what it is, what it's doing, or what it will do. Now we can prove if that's true. Beside that, are there any questions I may answer to? The thing is, the question is, will I use Terraform? Are there any situations I would prefer using Terraform versus ARM templates? Not really. There's one bad with Terraform. For instance, storage accounts are not yet deployable by Terraform, which is a pity. The cool thing is you have the ability to implement very easily custom scripts within Terraform, and you can use there whatever you want to. And sometimes I'm falling back to ARM by PowerShell or CLI bash scripts to do that job done then, if that special module I want to use is not available within Terraform. But for now, I really stick with Terraform. The thing about that is that real enterprise customers are more and more focusing on Terraform. The funny thing is you can combine in a single Terraform script multi-providers, which means deploying to Azure and to AWS is possible. You just have to respect the right direction of your dependencies. Okay, so here we have the plan. Look, we have the resource here. It is yellow tagged, not green, no plus. And there we have our tag. We've just added that app settings, right? And we have it here. So that means all the thing Terraform will do for us is adding that one to our application. And let's see if that happened. Boom. Here we go. That's our task key. And it is inside, and we have done our job. So Terraform is really awesome. The combination with Azure DevOps is really cool to forward and fast forward with your deployment. If you have any questions, feel free to ask. Martin.
Ah, sorry, I was muted. So yeah, I have a question.
Okay, shoot.
So what if you have an existing resource group which with existing resources in it? Because as far as I understand, the stagefall won't it delete the resources, or how can you work with existing resource groups?
So if you try to deploy a Terraform script towards a resource group which has the which contains already the sources you want to deploy, Terraform fails with already exist. To avoid that, you can do an import job with Terraform, which will set up the state file, and you can follow up then with Terraform containing CI/CD your project. Does that answer your question?
Ah, it does. Perfect. Nice. Okay.
Okay, cool.
We got another question from Heiko Strumpf. Can you share the example, maybe on GitHub?
I will do the. I will publish my example. Yes, you can have it. We'll do right in next week. Okay.
I guess the one question above was already answered.
Right.
What you would prefer?
Yes, I've answered that already.
Sorry about that.
Oh, no problem. Welcome back, Thomas. Okay, boys and girls outside there, if you don't have any questions, let's open a beer. I'll be right back in a couple of seconds, grabbing my beer from the fridge. I hope you do as well. What about you guys, Thomas and Martin?
My beer is cold, but I need to go 3 flights of stairs down to get it. So if we have the time, I'll do so. Do you want to do like a Q&A or?
Yeah, I want to have a Q&A if possible. That would be very nice. And you guys should open your video again so that the folks can see you after you're back from grabbing your beer. So sure. Give us please 30 seconds break. We'll be really right back here.
All right, I come up with some questions if you want.
So looks like I'm better prepared. Wait. I'm back.
And me. Having some real good Bavarian stuff here.
30 seconds is not enough time to pour a Weiss beer.
No, that's true.
No, it's not. No, you can actually see it.
Oh yeah. Cheers. Cheers. And cheers to the folks outside there. I hope you're sharing with us a beer for now. It was an amazing session. Thanks for watching us. Don't miss to put the thumb up, hit subscribe, and stay connected with us here. Thanks, Martin, for your time as well, and Thomas.
Thanks for the slot.
Absolutely. Thanks so much, Ralph, also for preparing everything and also talking, sharing your session. Very cool stuff. As usual, if there's anyone out there who wants to be part of this, who wants to maybe share some real-world scenarios regarding Azure or has some cool topic to talk about, please let us know. We're very happy to have different speakers on here. Doesn't matter if you have a lot of experience or if you want to get your feet wet. So yeah, reach out to us in case you would like to be part of the meetup.
Yes. And we hope to be right back in face-to-face meetings as well. Looks like at end of year it could happen. We hope.
Fingers crossed.
All fingers crossed. And for those of you who are keen to answer our questions, what did you like and what can get better for the next time? So please don't hesitate to let us know. Go to menti.com, use the code 650473 and answer that question. And yes, for sure, we've done that already. The physical meeting is not replaceable by virtual ones. We know that. I'm sorry for that, but we hope to get back soon on stage. So share your thoughts with us. Let us know what went bad, what went good, what did you most like. That helps us. Cheers to you. It's really fun.
Yeah.
And the cool thing is, folks, you might don't know that, but there was an average of 30 followers during the whole session.
Nice.
Really awesome. And we had some cool we had a cool share, some cool shares on or tweets, like Nico's tweet about his cool video beam wall with the logo. I don't know if you've seen that.
Oh no, I missed that.
Yeah, you have to look about that, man.
I will.
And then we had the sharing for Marcos and others. That's really awesome. And if you share afterwards, here's my promise: the first 10 of you get really a cool giveaway. Hey Martin, you have to share something, right? You are the very first Azure hero, right? The Azure community hero.
The badge you sent me?
Yeah, it's what? It's a badge. Yeah, it's a
reward.
It's a
Yeah,
reward.
thank you for that, Ralf.
Yeah. So go and share something with you now, because that's really awesome. Look at this. Can you see that?
Not
No,
yet.
we can't actually see you, Ralf.
Yeah, you have to see it on.
In 30 seconds, you mean?
Yeah. Here you go. Isn't that nice?
Well, I mean, you could always share yourself in Teams and
No,
take
no.
yourself off.
I hope you're seeing that. You will see that in a couple of seconds. The thing is that the folks won't see me if I'm using the camera twice. It's no point.
Now I saw it. The shirt. It
Yes.
looks nice.
Yeah, cool.
Looking forward.
Yeah. Tomorrow it goes on the way to you. I wanted to have it tonight to share that with you. And congrats to that award we've initiated with you. And we do have indeed 2 heroine already, which is Pina Meisel and Julia Schmidt. They'll get their shirt as well. That looks a bit different towards yours. I'm gonna share.
Because they're Romans?
Oh yeah, man! Look at this. Got it?
Not yet.
The delay is really huge. So this is really
There
amazing.
it is.
Nice one.
Yes. Supporting the community is always worth, not only for t-shirts. What is the biggest takeaway of today's meetup, Martin, for you?
For me, probably that the release pipelines are still a thing in Azure DevOps, to be honest.
Mm-hmm. I was surprised same way.
Yeah.
And Thomas, for you?
I definitely need to take a closer look at GitHub Actions for sure.
Yeah.
I'm completely in the DevOps space for now, but so I'm actually have projects on GitHub and I import them into DevOps to build them and release them. I guess there's a lot of potential for optimization there. So this is something I'm going to look at quite soon, I guess.
Got it.
If you're familiar with Azure DevOps, it's very easy to get into.
That's good to know.
Yeah, I suppose so. It looks very similar.
Yeah. It's because probably a lot of the guys who developed the Azure DevOps pipelines probably working on the same technique with GitHub Actions, I guess.
And the VMs that are available are probably quite similar to what's available on Azure DevOps, right?
I didn't compare it, to be honest, but I would imagine yes.
Copy that. Okay, what a night. Looks really good. I again want to thank you, Thomas, for supporting us that huge way. Martin, it was a pleasure. I appreciate it very much to have you on stage tonight as well. And same goes out to Mark and Nino, whom's already in their well deserved eve with their families and so on, because they had a tough day. Thomas and me were hitting almost the same challenge on Tuesday, where we've spent half a day with the online training format of Microsoft. What is it called? MSWT?
Virtual Training Week, something.
It was fun and it was exhausting, really exhausting. Martin, we had a call at that night. And
I saw it in your face.
Beside fun, it was really exhausting. Okay. All I have to say, or all we have to say for now is, what can we say? We can say, thanks a lot watching us. It was fun. Stay with us. Stay connected. Stay at home and safe. And we'll be right back with the next meetup, I guess next month. Thanks for watching us.
Looking forward.
Bye now. Take care.
Bye, guys.
Thanks, everyone. Take care.